Hello everyone. Whoa. I'm Shai Almog, and today I want to talk to you about cloud-native debugging in a Polyglot environment. First, a few things about me. I've worked for 10 years at Sun Microsystems, at a consulting company for 10 years, did lots of stuff for decades on end, founded a couple of companies, wrote a couple of books, did a lot and lots of open source code, and all sorts of other things. And right now I work as a developer advocate for Lightrun. I talk a lot about APMs and about observability. I sort of use them as a generic term for observability tools because these are some of my favorite tools. I just love APMs. They're absolutely wonderful. Because I'm old enough to remember the time before APMs when we wanted to see if the server was working and we had to physically go over and kick it a bit to hear the hard drive spinning. And this is just so much better. Getting a graph that sort of shows how everything is working in production at the scale. I mean, it's absolutely amazing. I usually say there needs to be a German word to describe the type of satisfaction you get from a well-running production system with all of those graphs in place. It's absolutely wonderful, and I would never give up something like that. It's absolutely great. But APMs have one missing aspect to them. They can show you an error rate in a web service. They can show you all sorts of things of that type. But they can't show you the line of code that's broken, the specific problem, literally point you at the error itself, only at the general direction. But I want to take a bit of a step back and talk about a different line. I want to talk about this one. This is a line that separates the developers from the DevOps. And this is one of those lines that we sort of drew out of necessity, because before we had that specific line, well, I don't want to be too dramatic, but before we had this line, developers, well, irresponsible developers like myself, kind of caused stuff like that, like the fail whale and things like that, which is why we invented DevOps and said, okay, the responsible adults should take care of production and not children like myself. And I'm saying children despite nearing 50. So this is really a matter of essential structure. We need the DevOps and we need that line. That line is a really, really good line. But that line also makes it very difficult for us to debug things in production, because DevOps know how to fix the DevOps stuff, you know, the out of storage or out of memory and things that are more oriented toward their skill sets. But going into my Java code and finding a problem within a bug that I made isn't something they want or something that they should do. That's my responsibility. But if it only happens in production, we have a problem. But we don't want to take back the accomplishments we got thanks to that specific line. We like that line. And I don't want to say that that line separates us from DevOps, just separates our responsibilities. We shouldn't touch production. I don't want to touch production, but I need to touch it responsibly. And this is what this talk is about. And I'll talk a lot about bats. I like bats, bat people. And one of the things, my association for this whole thing is the bat signal. And the bat signal is this great thing. It's kind of like an APM in that sense. It tells us there's a problem. It tells us Gotham needs our help, right? You know, we're like the superheroes in that situation. And the problem is it doesn't tell us where that help is needed. It just shows a general direction. And then we're kind of stuck there, looking left and right, trying to figure things out, looking through logs, trying to find a specific area that matters. And this is a bit of a problem because, you know, the log might immediately point you to the right direction. And definitely, if there is a problem, the first place you should look is the logs. But a lot of times it's just looking for a needle in a haystack. And the problem is that needle isn't necessarily there. We might end up in that sort of situation where we see a problem in production and the needle might be there, but we don't recognize it, or it's physically not there, and we need to somehow get that additional information. And when we are in that situation, this is a pretty common situation, then we have to add a new log. And when we add a new log, then we need to open a PR for that. And when you need to open a PR for that, it needs to go through code review. And I don't know about your companies, but when I go through code review, it takes a while. It literally is the reason I stopped being a developer and chose to become a developer advocate. I literally hate code reviews so badly that I chose to quit my job and move to a different role. It's painful. And as the company grows, it becomes more painful. And as you scale, it's torture. So this whole process, and then you go through CI/CD cycles, and then if you're lucky enough, you get to production. But the problem is, by the time you got there, that issue might not be reproducible because you need the person who actually experienced the problem to maybe cause it again. So by now, that person, that user might be gone, and you're sort of stuck. There was a bug, maybe there was a bug, it's no longer reproducible, and you sort of let it go until it comes back and really gives it to you. So this is terrible, but it's worse, and I want to tie this to one of the things that I like in this conference is the environment. If you use CI/CD so much, and I love CI/CD, CI/CD is great, it revolutionized our industry, but it takes a lot of electricity. And as we talked quite a lot in the past few days, couple of days, this is terrible for the environment. And when you just want to add a log, that's not debugging. That's sort of going through a huge process in order to do something tiny. And that's a totally wrong process. And I personally, I don't hate the environment. But if you hate the environment, do that. Okay? So I totally don't. There just has to be a better way to solve these sort of problems. Because, you know, it's 2022, and logs are still the way we solve problems. I mean, I love logs. I recently wrote a blog post on how to log properly and what to log and everything, and I put a lot of work into that. I have another talk about it as well, not here. But they're not meant for that. They're not a debugging tool, they're logging. And they're great for instrumentation, they're great for lots of things. They're not good for that, even though they improved tremendously in the past 10 years and from what they used to be. The problem is, we're not clairvoyant. We don't know in advance what we're going to need, when we'll need it. We don't know what to log and what not to log. We might overlog, which is a huge and expensive problem that people sometimes miss, because ingesting your logs into Elastic can become a huge cost, and the fact that you overlog can significantly increase your costs in terms of servers, and it's one of the main reasons that people have scaling problems when you log way too much, and it also makes the logs less readable when you actually need to go through the flow of this led to that. So this is generally a huge problem. So now the automatic answer is, well, we can debug. And when you're running locally, yeah, that's great. But obviously, reproducing things locally isn't always practical. And currently, that's one of the main things that we do when we have a production problem. We say, oh, I'll try to reproduce it locally. But that's really difficult, especially when the problem doesn't have a proper description. And also because of the situations of scale. A problem that happens in production is an environment that, even with Kubernetes and tools of that type, still very different from the environment that you see in production. So it's really difficult. So the option is to debug in production. Now, debugging in production is, in a word, and I'll be gentle here, bonkers. And the reason for that is, well, there's several reasons. The first one is, I used to say that debuggers are insecure. That's a total lie. calling debuggers insecure would imply there's any security whatsoever. Debuggers are giving your keys and address and literally your entire code to a hacker. Go ahead, use it, be my guest. If you put JDWP in production, go right ahead, give it to them if you provide remote debugging. There are some solutions that work partially. I actually have another talk about that as well. Talk to me later if you're interested. That let you do these things like SSH tunneling, port forwarding, things of that type, but it's still a security issue. And there are CVEs about products leaving JDWP open in production, even if it's for the local machine. So I wouldn't do it, and it's a problem in that sense. But that's just one of the small problems. Another problem is, a great example is if you put a breakpoint, it's stuck. And I can't think of a production environment where it's okay to stop on a breakpoint. Now, there are workarounds for that, but they're problematic and tricky. I heard a story 20-something years ago. So I don't know if it's an urban legend or not, about a person that was debugging a railed system, a system on rails on a cliff, and he stopped at a breakpoint, and that was when the start drive command started, and the stop drive command wasn't reached because he was stopped on a breakpoint, and a railed system fell off a cliff into the sea. Now, it might be an urban legend, like the airplane turning over with the F-16 when it went to the other side of the southern hemisphere. It might be an urban legend, but it's plausible. You know, you're stopping on a debugger breakpoint in production, not a great idea. What isn't an urban legend is the fact that debuggers crash a lot. It's very easy to crash a debugger with even bad watch expression or things like that. Debuggers weren't meant for that. Debuggers are allow writing to the production system. So a malicious engineer from within your company can literally log in with the debugger, elevate his permissions, and essentially steal everyone's money, or place a breakpoint on the user authentication code and steal all the credentials. It's kind of problematic to have debugging in production, and 60% of the break-ins into organizations are from within. So, you know, if you debug in production with a regular debugger, then, well, I'm sorry, but that's irresponsible. So that's not really an option. And finally, and to me, probably one of the biggest things, they can't cross boundaries between servers and do essentially at-scale debugging. When I debug a Kubernetes cloud, I want to essentially follow a user around, and that user might hit one server now and another server later. It can be pretty big. So a regular debugger following that person around, following that user across languages, that's really, really, really difficult. And it's possible to do that with a debugger. You know, if you're tenacious enough, you might be able to do that. But it's absolutely insane, and I think by now I'd rather go back to that CI/CD nonsense and burn a few trees and kill a few rabbits as a result of global warming, rather than go through that. It's pretty terrible. So I want to go back to this a bit, because I do love APMs. And you know, one of the things that I feel about APMs is that people sometimes look at them and kind of their performance overhead is a bit of a problem for some organizations. And I think that's sometimes a bit overrated. APMs, they work by instrumenting everything. They need to show us these beautiful graphs. So they need to put their measurement instrumentation into literally your entire application. And this works great to show the graphs, but it has an impact on your performance, on the overhead. And this means that some organizations avoid APMs as a result of that, because they think that APMs impact performance. Now, if you do things like high-frequency trading and things of that type, I get that. That's a special case. That's out there. But that's completely different. I think for most people who work with APMs and who work with these tools, reducing your footprint with APMs isn't a big deal. You can essentially limit some of the data that they take. All APMs let you check at a lower frequency, get less data, and impact performance to a lesser degree. This obviously depends on the type of application and what you're instrumenting with your APM. But one of the downsides of that is that you get less data. So when you tune up an APM, you get a lot of data that might help you for debugging some cases, but then you pay a price of performance that's completely untenable. On the other hand, when you tune it down, you get a lot of valuable information, but then they're not as useful for debugging. But another thing is that APMs were designed for DevOps. They weren't designed for us. And this is a general truism for most observability on monitoring tools. They were designed for DevOps. And that's important because DevOps need a big view of the system. They need to understand the system as a whole. We usually don't need that. We need something different. And here's the thing. APMs are great, logs are great for the right purpose, but we need something more. We need another team member to sort of do something different. And still keep this slide in place because we need this. We need that sort of separation. We need to work together with the DevOps and not against them. We need them on our team to do that part. And that's where developer observability is sort of a new pillar of this industry, essentially, that allows you to observe production systems from a developer's perspective. Now, if you Google observability and look for a definition, you'll pretty much find as many definitions as you find results, because everyone defines observability a bit differently, and that kind of sucks. But one thing that we have in common, I think, in pretty much all of the definitions is this. Observability is about looking at a production system and getting information about it without shipping new code. The without shipping new code portion, that's key, because we want to be able to understand a production system without going through that whole cycle of CI, CD, and all of that nonsense. We want to be able to get a deep view into our system. And here, with developer observability, we can do that. Developer observability takes observability to a new layer. It's designed for us, developers, and not for DevOps. And the way in which it's designed for us is, first of all, it's integrated to our tools and provides information of the type that we need. So, for instance, a DevOps-oriented tool for observability would talk about a web service taking such and such performance and working in such and such way or failing in such and such way. For us, what we care about is a source file system. I want to know the line in Java, what's going on, what's the value of this variable, or what does that method return. These are the things I care about, and that's what developer observability is about. The second thing it's about is about asking questions instead of instrumenting everything. An APM works by instrumenting the entire application. A developer observability tool instruments the point you ask. Now, I'll give you an example. A debugger is a developer observability tool. It's only local, so it's not a real observability tool, but it works in pretty much the same way. We can go to a specific file directly in our IDE, put a breakpoint on a line, and that's essentially asking the debugger to stop at this point. And the debugger then gives us the information about that specific point. A developer observability tool works in pretty much the same way. You place an action on a specific line and then get a response for that specific line. So things work directly with the code, and they work directly from within your IDE for some of these tools, not all of them, which is part of being designed for the developer mindset. And this is generally how it works. I'll explain the approach that Lightrun is taking, but this works for pretty much every developer observability tool. Where it's different, I'll try to highlight that. So usually you have plugins for an IDE or command line or a website where you can sort of place break actions on a code for a specific line of code. And here, unlike a debugger, you connect to a server. So the server can be either in the cloud or on-premise, depending on the company. Lightrun contains both. And this server essentially holds your requests. So your connection to production is always through this management server. And this is important because with JDWP, you connect directly to the production environment. And here you don't. You don't have any access to the production itself. It all goes through a server. And the production environment has agents, literally a Java agent in the case of Java, which connect to the server and then broadcast the results back to your IDE all through the server only. So you don't even know the IP address or anything about the production servers. You only communicate, your IDE essentially, or your command line only communicate to the server that manages the production environment. The DevOps people need to integrate the agent into their deployment process, and that agent can essentially, from then on, it's no longer their problem. From that point on, you essentially relieve them from the burden of dealing with all of your needs for debugging. So for them, it's a win of hearing less from you or me. And for us, it's a win because then we don't need to go through that whole thing. It keeps that line is kept 100%. So it's, yeah, I know I've heard that thing before, that, this new technology, when compared to APM, it's so low overhead. APM, it has performance in the name, and I'm saying that this has low overhead relatively. Now, this is true for all developer observability tools, that it has relatively low overhead, and that's sort of a feature of the way that they work. The reason is that it's just not an APM. An APM, as I said, needs to instrument everything. Developer observability tools, on the other hand, give you far more information than an APM, so they should be far more expensive, and that is true, but they only look at one single point in your application. So instead of getting very little information from all over, it's getting a lot of information from one single point, and that is obviously less expensive overall because it's just one point. But there's a loophole. So what if that single point is the point where all the traffic of your application is coming in right now? So you have an application with lots of throughput, and just on that area of the throughput, I'm injecting a log with more information in and getting all sorts of additional information. So this is a pretty problematic thing, and it indeed can lead to that. But some developer observability tools contain the ability to detect over usage of resources and throttle the usage of the tool. So if you log too much or do too much in general, it will be throttled and things will work as you would expect. Now, I'm going to show a demo, because explaining that, I can explain it all the time, but when we actually see it in production, it makes more sense. So this is all possible with the free version of Lightrun, which you can download. It's actually free, not a trial or anything like that. There's obviously when you scale, it's a different thing, but totally free. So let's move into the prime main application in Kotlin. It's a simple loop over numbers, and it checks if they are prime numbers, because our CTO is obsessed with prime numbers. It sleeps for 10 milliseconds, so it won't completely demolish the CPU, but other than that, it's a pretty simple application. It just counts the number of primes it finds along the way and prints the result at the end. We use this code a lot when debugging since it's CPU intensive, and yet it's very simple. So in this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. So the simple tool to have is the ability to inject a log into the application. We can also inject a snapshot or add metrics. I'll discuss all of those soon enough. So I'm selecting log, and that opens the UI to enter a new log. I can write more than just text. In the curly braces, I can include any expression I want, such as values of variables that I included in this expression. I can also invoke methods and do all sorts of things, but here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes the application state, the log won't be added. I'll get an error. So this is read-only. I can't damage the application. I can invoke a method in those curly braces, but if that method calls a method that calls a method that calls a method that changes something, it will fail. If it starts calling lots of methods that will take too much CPU, it will fail. If it does anything that's the least bit risky, it will fail instantly. No cost for the agent or the server. So I click OK, and I've got a new log injected. Now, in this case, we just see it up here, and now I can see it piped into the IDE. Now notice that after a few seconds, I get this line right here in the bottom. So I don't know if you can see it from back there, but the log point is paused due to high quota rate until for a few seconds until it's done. And this is sort of an important thing because that means that we can't overlog. Because this point in the code is very expensive, it loops a lot, this will stop it from eating up our server CPU and won't let it log too much. Because I'd rather lose logging information than lose a server, right? And think about if you would have logged it in production, if you'd actually added log in the code, it wouldn't have done that. You would have actually eaten up the CPU. So this is actually better than writing a log in the code because it protects you from that overlogging sort of overhead thing. Right? So one of the things I also want to mention here is in this particular scenario, I chose to pipe the logs into the IDE. The default behavior is actually to send the logs directly to the rest of your logs. So if you pipe all your logs to Kubernetes, to Elastic, to things of that type, it will also behave just like all the other logs. So you have a log written in your code, then you have suddenly a light run log, and then your log. And they'll be integrated based on the same order that they appear. So you can actually read the logs and see, oh, it did that, then it did that, then it did that. And you can inject that directly into production. And that's super valuable when you're actually trying to read something. So that's a relatively simple demo. The next thing I'm going to talk about is, well, a Netflix clone that essentially I wrote to sort of debug, show you how to debug these sort of complex polyglot environments. So I'm a terrible, terrible, terrible React developer. Absolutely terrible, and I guess, you know, the things that you don't like, you're not good at, and I'm not good at React, and I do not like it. So I hired a guy to sort of do that on Upwork, for real. I literally hired the guy to do that work on Upwork because I was lazy, and he did that job. And I don't like it so much that I asked him to do the bit of the front end as well as a bit of the back end, and he doesn't know Java. So he did that in Node.js, which is great. Node.js handles web stuff really good. But if you want to do database stuff, transactions, and stuff like that, well, oh, that's terrible. So that portion, I'm really good with Spring Boot. I love Spring Boot. It's great. It's wonderful. So that portion I did with Spring Boot, and that's sort of the application that we have going here. So this is the app that will take over the world. It's kind of, you know, like Netflix a bit. Well, nearly as good, right? It's like so close. And as you can see, you can go select movies, do all sorts of things of that type. There's a list of movies fetched from IMDb, and you can just scroll through everything, pick something, like here we'll go to Clifford, and click that, and yeah, and shows the movie, and it all works pretty much as you would expect. But here's the thing. If I go and click on James Bond, I get red notice. Now, that's a bug, and that's something I'd like to investigate. So let's go into the code again, and this time in Node.js. And instead of a log, I'm going to inject a snapshot. Now, a snapshot is a non-breaking breakpoint or a capture in other tools. A snapshot is literally what you would expect from a breakpoint, but it doesn't stop. Why it doesn't stop? Well, you don't want your rail system to fall into the ocean, obviously. Same thing with production. But you still can get a lot of information from looking at a breakpoint, from looking at the stack trace, from looking at all the variable values, which we'll see. So I add a snapshot. It's a standard dialog. I press OK. I won't bore you with the details. And you get this sort of lovely icon over there with a camera thing. And that's all good and great. Let's go into the app, click again on James Bond, and now we get red notice, and now we can go back, and okay, this got hit. Okay, so what we see here is essentially a view that if you work with IntelliJ, it should be pretty familiar to you. You know, you've got the stack trace on the left. It's relatively big because, well, JavaScript still. And you see the values of the variables. And you can inspect everything. Now, because it's JavaScript, there's not much to see here because, you know, even if you would debug JavaScript natively in their IDE, you wouldn't see much here. But you can see the value of the variable which represents the ID of the movie. And I can tell you this is the correct ID, which means the front-end code doesn't have the bug. That's the right ID of the James Bond movie, and it's passing that ID to the backend. So we need to move to the Spring Boot backend and sort of place a breakpoint there. So I'll go into the Spring Boot backend, and in the Spring Boot server code, we've got the fetch movie details method, which does the actual fetching. I'll place a snapshot here, and I'll spare you the pain of going to the web every time. I have a crawl command that performs the request, so I'm running it in a different window here, as it's not really interesting. So now we need to wait for the snapshot to get hit. This seems to, take a bit of time, but, we can wait here for quite a while, and a spoiler, it won't get hit. And the reason it won't get hit is the cacheable annotation up there. If you're familiar with Spring Boot, cacheable sort of caches pretty much what you would expect. So that means that value is already cached, and we just don't reach that method. So this means the data in cache is corrupt. So let's go and verify. Here's the REST request. And I'll place a snapshot here instead and do the same thing. OK. And now let's wait. Here we go. So after a bit of waiting, we finally hit the snapshot in the get method. This means our request is happening, but the failure we're seeing is because of the cache, and it got corrupted with bad data. So can we continue the investigation? And by the way, before we continue, notice this is a beautiful stack trace from Java. Part of why I don't like JavaScript and love Java. This is a proper stack trace. This is a proper variable values. Lovely. So let's continue. So here's the place where cache might be corrupted. In check for file updates, the method runs periodically every 60 seconds and checks the file system for import file. This is how we add new movies into the system. We place the file data and import it into the database. It might break existing movies. So essentially, this is a pretty common pattern of importing a file. So let's create a snapshot. And while we wait a minute for the snapshot to hit, I'll delete some of the existing no longer used snapshots from before. They'll eventually expire, but they're here in case you need reference. One of the nice things about debugging snapshots is that normally you don't have to wait. You can just place them all over the code, and they get hit at some point, so you don't need to reproduce. You can go get coffee. So the snapshot got hit, and I can go here and see the stack trace and just in time. So this code is working. Now, all I need is to evict the cache with the dummy file, and we're done. Or are we? Notice the methods here. The batch update evicts the cache, or so it would seem if you're new to Spring, which I'm not, so surprised that I made that bug. But notice the cache evict method. So it's supposed to evict all the movie details cache from Spring, but because if you notice the method is invoked from within the same class, then the annotation isn't read. That's how Spring works. Spring only performs the annotation method when invoked from a different class, because then you go through a proxy method, proxy class. So because it's a call within the class, you won't notice it, and no one noticed that because we keep redeploying, because it's a system that's live and gets redeployed. So we only notice that when things are running smoothly for a while. So that's a bug, and pretty common, unfortunately. So this was relatively simple in terms of observability. So let's up the ante a bit and talk about some user-specific problems. So here I have a problem with a trending request. One specific user is complaining that the trending list on his machine doesn't match the trending list for his peers. The problem is that if I put a snapshot, I'll get a lot of noise because there are many users reading all the time. So the solution is to use conditional snapshots. Just like with a regular debugger, you can use a conditional breakpoint, and notice that conditions you can put on logs, you can put them on snapshots, you can put them on metrics as well, which we'll talk about soon enough. And this is another pillar of developer observability, the ability to put conditions and fine-grain your observability to pinpoint a specific bug. So I add a new snapshot, and in it I have an option to define quite a lot of things. I won't even discuss the advanced version of this dialog in this session. This is really a trivial condition. We already have a simple security utility class that I can use to query the current user ID. So I just make use of that and compare the response to the ID of the user that's experiencing the problem. Notice I use the fully qualified name of the class. I could have just written security, and it's very possible that would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE. So there's the import statements. If you know enough JVM internals and stuff like that, the import isn't an actual thing in the class file format. And the agent only sees the class file. It doesn't expose to your source code in any way. So things like generics and imports just aren't visible there, and you need to adapt based on that because of erasure and things like that. So keep that in mind. It requires some thinking. By the way, one thing I forgot to mention about the Kotlin code I showed earlier. Notice I wrote expressions there. If I write an expression in Kotlin, I'll have to write it using Java, not using Kotlin, because the agent is running in Java because it's a JVM. So we support Kotlin, we support Scala, etc. But the expression language needs to be in Java. And even then, you need to adapt to the fact that it's bytecode, so it's not real, Java in the IDE. So syntactic sugar is sometimes not the same. So some nuances, but it's not very difficult to get used to that. And we have great PagerDuty support, so that's very useful. So after pressing OK, we see a special version of the snapshot icon with a question mark on it. This indicates that this action has a condition on it. Now it's just a waiting game for the user to hit that snapshot. And this is the point where you can go make yourself a cup of coffee and everything, but I won't make you wait. I'll just send the curl request, and here we go. The snapshot gets hit by the right user, despite the other users coming in for this specific request and with the right user ID. And you can see the ID here in the and review the stack information as you would expect. So the next thing I want to talk about is metrics. APMs give us large-scale performance information, but they can't tell us lots of things about the code. And I want to show you a few things about metrics. So one of the things that I do a lot is I use logging for measuring things that are important in terms of timing. So for instance, one of the things I want to do is to know how many times a line of code is invoked. That's pretty basic. We all want to know that. And in production, it's probably the most valuable thing you can have. Is anyone using this method? Are people from Italy using this method at all? You know, sort of nuanced information like that we'd like to know about our system. Well, normally in normal code, I would just add a counter into the class, add a log that counts the number and constantly write that counter. Instead, you can just inject a counter metric and get that information. Same thing, you want to sort of measure the time things take, and ideally in production. So I use system current time millis a lot, and then I save the value, and then I log that value a few lines later, system time millis minus the number I took before, and then I have a value, and that's something I log. And this is far more fine-grained than anything. It's more accurate than a profiler. It's the best way to measure performance. But the problem is, doing that in production is really difficult because you constantly want to shrink the area that you're measuring, and you constantly want to move around. You want to add conditions to it and things like that. You want to measure at the way that developers measure, right? I mean, profiler is great and wonderful and everything, but it's designed for a different thing. We want to sometimes just get very pinpointed information. You know, is this method causing the problem? Is this method causing the problem? Who's using this method? Right? And I mean, not in terms of the code, because we know that, we know usage, but I want to know who's actually using it and actually in production, not locally. And these metrics allow me to do exactly that. I can do time measure, which is TikTok. I can select an area and say, okay, how much time is this area taking? Or select the entire method, which is method duration. It's all very, very useful in that sense. So measurements typically have a name under which we can pipe them or log them. So I'll just give this method duration a clear name. In this case, I'm just printing it out to the console, but all of these measurements can be piped to Statsy and Prometheus. I'm a pretty awful DevOps, so I really, really don't want to demo that in this case, but it does work if you know how to use these tools. And as you can see, the duration information is listed here, and I totally don't want to show this going to Grafana and everything, although it does work, and my colleague Tom will totally show that to you if you want to go that way. So unfortunately, we don't have that much time for the talk, so I didn't prepare the Airflow demo, and also because demoing Airflow is so painful. But there's a demo for Airflow in the full version of the talk where I show essentially the complexities of debugging these sort of things. If you're not familiar with these sort of APIs, and I have several demos related to that for Spark, Fleet, Kafka, Airflow, all sorts of APIs like that. They are very different from one another, by the way, obviously. Streaming and batch and workers and all of those sort of things. But all of them have one thing in common in the fact that they're very short-lived processes that go up and down all over the place. And one of the things that we can do here very easily is monitor these things coming up and down. There's literally no way to debug these things because the process comes up and then goes down. It performs a task and then vanishes. And a normal debugger can't even connect to something like that to debug it. But with a tool like a developer observability tool, you can connect. And actually, looking back at the demos, I recall that I missed a point there because it's live and I'm not used to that. Sorry, it's getting back to this. I showed you how you can place a breakpoint on a snapshot or log on an agent. Everything that I showed can be done to a tag. So if you have 1,000 servers, you can place a log on all 1,000 servers, assuming they have the similar tag, or you can place a log on the green servers, on the red servers, on whatever type of servers that you have. and all Ubuntu servers. You can add as many tags as you want and qualify everything any way that you want. And that way you can get information from pretty much all the servers at once and essentially debug at scale. And that solves that particular problem. So there's another thing I want to actually discuss in the summary, but again, with the cutting of the slides, I kind of missed that point a bit, and I'll get to that soon enough, and that's about security, so about privacy, sorry. So as I mentioned, we have support for these platforms right now, specifically in Lyra, and some of our competitors have more platforms, some have less, and it's, you know, it's a big field, but it's relatively new, so there's more and more coming up. As I said, when you insert an action, good products in this field wrap it in a sandbox, so check to make sure that everything is sandboxed correctly. In terms of security, again, everything is sandboxed and also behind servers, so you don't have an actual direct connection to the production. And this is the point I wanted to talk about, because previously when I was talking about debuggers, and I didn't mention GDPR, but that's generally it, the ability of a malicious developer within your organization to place a breakpoint in a bad file or log information that they shouldn't, like credit card numbers. So if you're familiar with PII reduction, that's personal information, identifiable information, which you can essentially remove automatically from logs. So if a person does a log and accidentally logs a credit card number, well, PII reduction can detect that pattern, the pattern of the credit card number, and remove it automatically. So this is supported, at least in Lyra. I hope that our competitors have it. I don't know, but you should check it if you choose to take a developer observability tool. It's an important feature. And another feature that's important is block lists. Block lists allow you to block specific files from having actions in them. That means if you have a user credentials file, you can literally block a user from debugging it. One of the nice things, I have a demo in the Lyra website where I show how you can debug a authentication process, right? So you can place a breakpoint directly in the authentication process and actually see the user credentials and everything. And that's really cool if you're integrating a single sign-on. You know, you're doing it for the first time, you want to see, oh, it works, and you can actually place a snapshot and actually see all the information about the single sign-on process, where it got, and everything. But obviously, huge security risk. So once you debug that, you need to remove it from the user's ability to detect. And again, I also mentioned the footprint in terms of CPU. It's relatively negligible. And the management server can be on-premise or in the cloud. Some support that, some support the other, some support both. You would need to pick the right solution there. So with that, we have 3 more minutes for questions. My details are right here, and I'd appreciate feedback and everything. And like and subscribe, obviously, right? So, thank you. So, I'm guessing everyone's hungry now. So,
I was just kind of curious about where Lightrun runs. So what I added is like a library to my program?
It's an agent. So Java agents work by you add a command line argument, kind of like a debugger when you run. Have you ever run remote JWP debugging? So it's sort of a similar argument that you add to your Java command line. Or alternatively, if you run through an application server, you add it through environment, through configuration. There's a huge list of install approaches. If you're using Spring Boot jar, it's really easy. It's just a command line. If you're using more complex deployments, then it's a bit more of tailoring, but we have a ton of documentation how to do that. So it's, but yeah, it's just, the agent is just a command line, kind of like, yeah.
And you were saying like it barely affects performance. Like it.
Yeah, when you don't have any actions and you have a really intensive application, it's under 0.5% in terms of impact on performance when an APM to the minimum configuration is about 8%. Totally worth it, as I said, based on our measurements. So obviously, vendor measurements, take it with a grain of salt, but that's what we did. With actions, the impact was still between 2 and 8%, depending on the action. Right? It's because essentially the way it works is it just sends a ping, and it's once every, so there's minimal impact.
Cool. Thank you.
Thank you.
How does it relate to the branch that is running in production and the branch that I have in my IDE?
The what?
So let's say I have the production branch deployed to production.
Great question, because that is a very difficult thing. So if someone is working on a different branch and adds a snapshot to that branch, then the line isn't correct compared to the class file that he has that you have in the agent. And then you have a problem. And indeed, that's a very difficult problem for these sort of tools. Every single tool solves this differently. One of our competitors works with Git directly, so they're only a web-based solution, and then they directly integrate to Git, and you need to select the branch there, and then it works perfectly because they integrate with your code. We have the philosophy of we don't see the code. We don't have access to your code at all or your Git, so we don't know about your branch. So one of the things that we do there is we have this sort of proprietary algorithm there that inspects the class file, generates a signature from the class file, which means the lines for every method and within the class, something like that, sort of generates a signature, then does the same thing in the client side and compares them when you send an action. So if you send an action, it also sends with it a signature of your current class file. And if they're different between the server and the client, it pops up a warning that says, well, maybe you're not in the right branch. Maybe the agent is working with a different version, and you need to check that what you're working with is the correct version. You can ignore it because it's just a warning. So it might be okay, it might not be okay, but it's kind of like when you debug with a normal debugger when the class file is compiled with a different version of the same file. So you can reach that situation. It's very, very perceptive.
Thank you.
Thank you. Great. Thank you all for being here. Sorry for keeping you from lunch, and myself.